Hello, everyone. Today we're going to talk about security design in the cloud. And the chapter starts by saying that data in the cloud cannot be secured. I believe there's a quote from a Stanford professor that says that the data is impossible to be secured, or alludes to that anyway. While it is difficult to manage data inside of a cloud, it is not impossible. Today we will talk about some strategies that will assist in making cloud security more manageable. And an important point to keep in mind is that regardless of where the data resides, the security has to be bundled, whether it is the traditional physical data center that was common several years ago, or the cloud-based systems that are more common today. It's not a matter of where the data resides. It's simply a matter of how much security is built into a system. Today we'll talk about some strategies that will make a system more secure and less vulnerable to security breaches. The regulations, cloud regulations, are very specific, and most standards will recommend, if not demand, that personally identifiable information such as demographic data, your ethnicity, gender, those types of information, your address, and your phone number, your social security number, certainly, credit card information and all financial information, bank account numbers and things like that, health-related information, all of those personally identifiable information need to be encrypted. The encryption, if there is a security breach, when the data is encrypted, regardless of the security breach, the data cannot be intercepted. It cannot be read, even if it is intercepted, as long as encryption is in place. There's a few standards that call for that. The Payment Card Industry Data Security Standard, the Health Information Portability and Accountability Act. Those are a few of the more prominent standards that require personally identifiable information to be encrypted. In 2001, shortly after 9/11, the USA Patriot Act became law, and that law says that if a data center is housed in an international location, regardless of where that data center resides, the United States government has access to the data from any United States-based company. Then Europe has also established the US-EU Safe Harbor Regulation, which says that there have to be controls in place before personal data can be transferred outside of the European Union. Most of these regulations have come about as a result of a major occurrence like 9/11 that has required the need for information and for Homeland Security and agencies like that to be able to access information to try to determine the underlying where the terrorist attack was funded, how it was funded, and the source of the finances. How much security is required? Well, of course, it's going to be dependent upon several factors. The industry, is it retail, is it healthcare, is it education, is it government? What does the customer expect? Customer expectations are very high. We have a low tolerance for security breaches, and we'll talk about that a little bit later on in this chapter. The sensitivity of the data being stored, how much risk can we tolerate? Of course, we talked about risk management and risk assessment and risk mitigation last week. The maturity of the product, the transmission boundaries. Now, if it's a business-to-business type of environment, then the security level is going to be higher. For example, when you go to an e-commerce website, of course, you're going in as a consumer. That's a B2C transaction. But once you hit the submit button and you submit that transaction, now it is the the responsibility of the company that you're doing business with to secure that transaction, and they usually manage that security through a third party. So when you hit the enter button and you go to process a credit card payment, for example, then a third party credit card agency will authorize your transaction. At that point, all data must be encrypted, and any communication between the e-commerce website and the credit card third-party website, B2B transaction, if you will, must be encrypted. So depending upon the nature of the transaction, that will dictate the level of security. Business consumer transactions, there is a tremendous focus on privacy. One of the things you have to decide when looking at security is who's going to do the work. Are you going to do the work in-house? Will you build your own in-house security? Or will you purchase security from a third party? Most companies today do not manage their own security in-house, but they do use a third party, either software or service or both, to integrate their security into their businesses. How will the security requirements be met, and when will the security requirements be met? Those are things that must be decided early on at the onset, if possible, or if you're inheriting security that's already been in place, then you have to implement new security standards and new strategies. How soon can you get those standards up and running? A best practice to leverage a combination of open source freeware. There's a few security packages that are available, or you can use security as a service. Just as we talked about software as a service, we know that CSI and Infor is a software as a service model. We can also use the security as a service model. Before we can implement security in a cloud environment, it is important to understand the cloud service models. We talked about them last week. We talked about infrastructure as a service. We talked about platform as a service. And we've been using this semester software as a service through Infor's Cloud Suite Industrial. The cloud stack consists of 4 categories, 4 layers, if you will. The user layer is at the top. User includes login, registration, administration. The application layer, authentication, authorization, user interface, transactions, dashboards, reports, that's probably a graphical user interface somewhere in the equation in the application layer. The application stack, the operating systems such as Windows operating systems or whatever the operating system that's being used by the server that's housing this cloud service model, the programming language, .NET, Java, Python, and so on, the application server, whether there is a web server, there will more than likely will always be a web server, and one or more database servers. You might have some middleware for communicating with internal and external vendors. The monitoring is part of the application stack. Then the infrastructure itself, the physical, the data center, the hardware, peripherals, printers, network infrastructure, routers, switches, circuits, hubs, and things of that nature, storage devices, the actual hard drives in the servers and things of that nature are part of the infrastructure. Infrastructure is more physical. So understanding that there are 4 layers and what happens at each layer is the first step. Here is a diagram, and there will be one diagram for each of the 3 models that we're talking about today. So if we're talking infrastructure as a service, the vendor is responsible for the infrastructure security, the physical security, and the customer or the company is responsible for everything else. So you have the user layer, the application layer, the application stack, and the infrastructure. So if we're talking about infrastructure as a service, then the vendor, the cloud vendor, is responsible for infrastructure security. The customer is responsible for everything else. The other three stacks, the user stack, the application, and the application stack. So it's a question of who is responsible. If it's an infrastructure as a service, then the vendor is responsible for the infrastructure. Amazon Web Services is infrastructure as a service. Okay, so then the next model that we talk about is platform as a service. Platform as a service includes both the application stack, which includes the operating system, the applications, the programming languages that are running under that application, plus the infrastructure. This is platform as a service. And then, of course, the customer is responsible for the user layer and the application layer. So in the platform as a services, the responsibilities are divided 2 layers for the platform as a service vendor, the application stack, and the infrastructure. And then the customer is responsible for the user layer and the application layer. All right, so then the next model is the software as a service. Recall that this is CSI's business model, and if you will remember, they are using for their infrastructure, CSI actually uses Amazon Web Services. So they embed the infrastructure as a service with software as a service, and then they are responsible for the application. So in the case of CSI, the Cloud Suite Industrial application, the database, the security for both, or for all 3 layers, for the application layer, the application stack, and for the infrastructure, required by a software as a service model, and the user again relegated to the logon, registration, and administration. So understanding the 3 models and who is responsible at each layer then allows for you to break the security requirements down into smaller, more manageable components. Once you have done that, then you can implement some strategies. Centralization is one of those strategies, which consolidates security controls, policies, processes, and services in a central location. It reduces the number of places where security needs to be touched. The trade-off, though, is that there is, in centralized environments, you have a single point of failure, which must be managed aggressively. Using industry standards and best practices, of course, is always a good idea. Authorization, encryption, those things are mandatory. Standalone set of shared services that can be shared across applications is a good idea, and that way you're not relying on each application to manage its own service, but rather you have services that can be deployed across the applications, and if you integrate additional applications, the services can also be shared across the new applications. It makes for a nicer implementation, and it certainly makes for easier integration. Security logs, error messages, warnings, debugging data, all of that should follow standard naming conventions and standard formats, so that when you have a series of security logs, they all have the same naming convention. You can look at them. Usually there's a date and a timestamp, so you can know which security log was the most recent and which one is the oldest, and so on. And you can go to a specific point in time as long as you have some formats and naming conventions in place. Automation is probably one of the most important things that can happen with cloud-based security. An automated script is ideal for a couple of reasons. First, it will make the security patches and updates easier. Second, it will reduce the manual errors that are introduced when you're handling security manually. Ideally, the script can be written and tested thoroughly before it's implemented, and you make sure that every component, every part of the model, the cloud-based model, is covered in your script. And then it's easier when you need to update the script. You make changes, you edit the script, you make changes to the script, you test those changes, you implement it. It's much easier than reinventing the wheel. Using an automated script is a best practice. Security controls, policies, and processes, all of those should be embedded in the script. Then, of course, detection, the mining, the logging, the looking for patterns, proactively trying to find security vulnerabilities. Those kinds of things can go a long way towards reducing the incidence of security breaches and mitigating the amount of damage that is done if a security breach occurs. Prevention, taking the necessary steps to prevent further damage at the first onset, at the first discovery of a security breach. Then there should be some mechanisms and policies in place that will allow you to bring the system down quickly if need be to reduce further damage. Policy enforcement has to be at every layer, at the user layer, at the application layer, at the application stack layer, and at the infrastructure layer. The best practice is to make the rules configurable, and again, put those configurable policies into an automated script. If you're using a tool like Active Directory, for example, it is easy to put the policies, the permissions and policies into a script and then leverage the script. Policy enforcement at every level, at each level, again, at the user level, the application level, the application stack level, and the infrastructure level is essential. Create a template. Template is an excellent idea. Something referred to in this material as a gold image. That image contains all of your security policies, your port management, and any encryption. All of that can be put into a template. The template then becomes the script. You modify the template based on the necessary changes needed, and you implement that template as your most recent script. You also use security protocols, HTTPS, known as SSL or Secure Socket Layer, which specifies the port and the IP addresses that are allowed to access certain information. You encrypt all data, whether it's in flight, whether it's being used, or whether it's just sitting in the database. At all stages, it should be encrypted. Make sure that the encryption keys are not stored in clear text, which kind of defeats the whole purpose, and that you are centrally managing in a very high secure data store your encryption keys. Web security, you have to use the web frameworks that come with many of the web platforms. You can use Apache has a web framework, and .NET includes a web framework. So those frameworks have built some protection into them against web vulnerabilities. Run the vulnerability scans to detect security gaps. And if a security gap is identified, try to get to it before it's discovered by those who are looking to do damage and harm, financial damage or some malicious intent. In the case of Equifax, of course, they found a security hole and they leveraged that hole and were able to breach 143 million user account information from Equifax. The problem was that Equifax didn't tell the consumer until about 6 weeks later, covering their bases before they informed the consumer. Very bad idea, and very costly, I believe it will be, to Equifax in the long run. Application Programming Interface Management, API. Use encryption keys rather than passwords between the client and the provider. Always use secure socket layer. Encrypt sensitive attributes, usernames and user information, for example. Only include information that's absolutely necessary when you're using that middleware. If it's not necessary to pass the information, then don't pass it. If an unauthorized user gets access, then reset the authentication after every request, which means that they get access once, but they don't continue to have access. Patch management, of course. Create an image with all the latest and greatest security patches at least once every 30 days. In that image, again, you can include all of the rules and all of the policies that need to be configured, and it can be written as a script and automate the deployment process to pull the latest image, deploy the new software and the new image based on that new gold image that's been created every 30 days. Retire the current production servers containing the previous version, and then simply run the script and you're back up and running with the new image on the new server. Automation and using templates and managing your patches will go a long way towards improving the security of a cloud-based system. Logging, of course, there should be logs at every layer. The user layer is automatically, when a user logs on, it is logged. The date, the time, and the username and the password is always logged, so that part is covered. But you also need logs at the infrastructure layer, the application stack, and the application layer. Every layer should have a security log. You can create a log for every event that occurs within a system. Of course, there is a certain amount of overhead associated with logging. The trade-off is that you have a boatload of data that can be leveraged and mined and looked at for patterns, for analysis, for investigations, for troubleshooting purposes. There's a variety of reasons to monitor and maintain logs. You can look at real-time activity. You can also look at historical data. It's a good idea. And if there's an audit, of course, the logs will be part of that audit, and I believe they need to be kept up to date for legal purposes if an audit is required. And of course, the service level agreements that we talked about earlier, the logs will go a long way towards looking to see if those service level agreements are being met. In summary, cloud-based security is difficult but not impossible to manage. Apply the best practices to both the applications and the services running on a cloud-based system. Monitor and detect security issues by using logs. Practice security prevention by addressing issues that are found in the logs. Being proactive, setting alerts on certain events, and that will then generate an alarm that can notify somebody that something is about to occur, or something has already occurred, or something is or a security breach is in process. If you're proactively monitoring, then usually those breaches can be identified and mitigated. Now, the one thing that we haven't mentioned here is that the security is only going to be as good as the employees who are managing the security. If a disgruntled employee gets into the system and wants to do harm, they will do harm. The Eric Snowdens of the world, the contractors and the internal inside people that are have their hands on the system, that is very difficult to manage, if not impossible. But I guess in most companies, they have watchdogs so that no one person is responsible for all security, but rather there's a team of security people, multiple people that watch each other as they watch the system. That's pretty much the only way to prevent a rogue employee from doing irreparable damage. Understanding the cloud stack and the 4 layers, the user layer, the application stack, and the infrastructure layer is essential for managing cloud-based security. Please let me know if you have any questions.